All right, so giving up on VV, but you can follow along in Zoom. All I've done so far is label the two equations. Here I go. What have I got here? I want to solve these equations using, oh good, it's going to have a delay, using the elimination method. So the first thing I'm going to do here is add those two equations. You see if I add them, the x's are going to disappear. Come on, behave yourself. 4y plus 3y is 7y. Plus 2x minus 2x, that equals 0. 8 plus 6 equals 14. Dividing each side by 7, I am going to get y equals 2. And it's really struggling, but that's okay, we got it. So I've got one solution, I'm not done. I need to solve for x as well, so I'm going to let y equal 2 in the first equation. So I have 3 times 2 plus 2x equals 8. You can see having Zoom open is messing with it a little bit. Hopefully you can still read that. All right, subtracting 6 from each side, I'm going to have 2x is equal to 2. Therefore, x equals 1. The simultaneous solution is 1, 2. Check it, make sure it works for you. You go back up to the original equations, and if I put 1 in for x and 2 in, we know the first one works. 8 minus 2 will give me 6, so we know we're right. Okay. On to the next one. I want to do elimination, but they're not set up nicely for elimination here, are they? I've got 2x plus 3y, and I've got x minus 2y. It's up to you how you want to go ahead and get these to eliminate. Rather than changing two equations, if I just change the x to 2x, I'm only going to need to change one equation. So I'm going to leave the first equation alone. And that's almost useless. 2x plus 3y equals 19. And I'm going to times the second one by 2. You can see how it was a little bit frustrating doing this, can't you? 2x minus 4y equals negative 16. Now, when I do equation 1 minus equation 2, those x's are going to disappear. 3y minus negative 4y means 3y plus 4y, I'm going to get 7y. 19 minus negative 16, add them together, I've got 35. Dividing by 7, y is equal to 5. Now I need to solve for x. I'm going to let y equal 5. Behave yourself. Oh, that's not an eraser. Let y equal 5 in equation 2. So I've got x minus 2 times 5 equals negative 8. So I've got negative 2 times 5 is negative 10. So I'm going to add 10 to each side, and I get x is equal to 2. Nice little concluding statement. The solution is 2, 2, 5. Well, that should be fun for you to look back and watch. Just check your answers again. 2 by 2 is 4, plus 3 5s are 15. 15 and 4 make 19. First one's right. 2 minus 10, negative 8. We're happy with that. All right, just basic index law work here. Let's just go ahead. 4 to the 3 times 4 to the 5. Add the powers. 4 to the power of 8. 9 to the 7 divided by 9 to the 4. We subtract the powers when doing division. This is 9 cubed. It says simplify, give me your answer in index form, so I don't need to evaluate those. X to the 2 times another x. That x on its own has a power of 1. Don't forget to add it. This is going to be x to the 2 plus another one is 3 plus 6. X to the power of 9. 3m to the power of 7 divided by m squared. Well, 3 divided by 1 is still 3. M to the power of 7 divided by m squared. Take the 2 m's away, and I'm left with m to the power of 5. Multiplication, numbers first. 2 5s are 10. A by a squared is a cubed. B squared by b cubed is b to the power of 5. Last one here, fractions to simplify. Just go number by number, letter by letter. 9 divided by 12, 3 goes in each of those. It goes into 9 3 times and into 12 4 times. 5x's on the top, 3x's on the bottom. 3 of them can cancel, and I'm left with x squared on the top. 4y's on the top, 1 on the bottom. 1 of them can cancel. I'm left with y cubed on the top. So our final answer there, 3x squared y cubed divided by 4. Nearly there. Evaluate 2 to the power of 5. Just count along on your fingers. 2, 4, 8, 16, 32. 2 to the power of 5 is 32. Negative 4 cubed, we talked about this before. When I have a negative and I cube it, it becomes a negative. If it's an odd power, a negative raised to an odd power stays negative. 4 times 4 is 16, times 4 is 64. Negative 64 is our answer there. For each of the following, find the value of x correct to 2 decimal places. Label your triangle first. Opposite, adjacent. So in this case, I would need the opposite and the adjacent side. That's tan. Tan of, come on, tan of 38. Try that again. Tan 38 is equal to the opposite x divided by the adjacent 6. Multiply by 6. 6 tan 38 equals x. Come on, little calculator. Now, it says to answer correct to 2 decimal places. Someone's going to have to help me out here. I do not have a calculator on me. X is approximately equal to 4.6. Sounds a little bit small. Now, it could be that your calculator was in the wrong mode. If you go 6 times tan 38 on your calculator, tan of 45 is 1. So it should be a little bit, oh yeah, 4.6. It is right, 4.6. 697. So we've got to go to 2 decimal places, so 4.70. Excellent. That was right. I was thinking of the wrong thing. I thought you said 0.469. 4.70. Too many things to worry about. You did it correctly, of course. If you're getting a different answer when you do that, it's because your calculator is in the wrong mode. So just check the mode your calculator's in. Again, labeling my triangle here. Hypotenuse. Oh, I think I'm going to go back to Vivi disconnecting after this. Hypotenuse, opposite, adjacent. So I'm looking for the adjacent side. I know the hypotenuse. Soc, car, toa, cosine, isn't it? Adjacent and hypotenuse. So I go ahead and I write that. Cosine of 53 equals the adjacent side x divided by the hypotenuse 17, multiplied by 17. 17 cosine 53 equals x. Therefore, x is approximately equal to, well, we know your calculator's in the right mode. What do we got? 10.32. Yeah, that seems reasonable, doesn't it? It's got to be smaller than 17. That seems pretty good to me. Couple to go here. Label your triangle. Hypotenuse. Opposite. Adjacent. This is another sine one. Sine of 42 equals the opposite side, 10.5, divided by, I don't like it when my x is in the denominator, so I multiply through by x. X sine 42 equals 10.5. To get x on its own, I've got to divide by sine 42. So x equals 10.5 divided by the sine of 42. X is approximately equal to, you help me out again, Robin? Sorry? 15.69. Does that seem reasonable? Yep, it's got to be more than 10.5. That's pretty good. Lucky last here. Label your sides. Opposite. That was the hypotenuse. This is adjacent. You can almost read some of those letters. How helpful. Opposite and adjacent involves the tangent ratios. The tan of 41 equals 0.3 divided by x. That's the same as saying x times tan 41 equals 0.3 divided by tan 41. So x is approximately equal to 0.35. And there you have it.